Good afternoon to one and all present here. Respected Principal of MAHAGURU Institute of Technology, Dr. Manju Ma'am, Head of Department of Electrical and Electronics Engineering, Mr. Rahul P. Raj, faculty members of Triply and other branches, and also my dear students. A warm welcome to all to this session. Today, we, the Department of Triply, organizing a webinar on the topic Renewable Energy Applications in Smart Grid, Microgrid, and Electric Vehicles. And our resource person is Ms. Nithara PV, Assistant Professor, Triply Department, CMR Institute of Technology, Bangalore. Ms. Nithara completed her BTech degree in Electrical and Electronics Engineering from CUSAT University and MTech in Power System from Calicut University. She has a 4.6 year of experience in teaching and 1 year of industrial experience. Currently, she is working as assistant professor in Department of Electrical and Electronics, CMR Institute of Technology, Bengaluru, and pursuing her PhD Amrita Vishwavidyapeetham, Bangalore. She has 2 Scopes Index journals and 6 conference articles. Her area of interests are DC microgrid and renewable energy sources. I welcome you, ma'am, on the behalf of Triply Department and Mahaguru Institute of Technology. Thank you. Ma'am,
Uh,
you
o-
can start.
yeah, ma'am. Thank you, ma'am. Thank you for wonderful introduction about me. Good afternoon, everyone. I'm Nitara Pevi. I will be continuing now to take a webinar. So let me share my screen. Ma'am, are you able to see my screen, ma'am?
Yes, ma'am. It's,
Shall I start, ma'am?
okay, ma'am.
Yeah. Okay, one more time. Good afternoon, everyone. I'm Nitara PV, Assistant Professor from CMR Institute of Technology, Bangalore. Today, I'm going to give a webinar on the topic of renewable energy application in smart grid, microgrid, and electric vehicles. First of all, from the title itself, I want to explain you something about what you mean by renewable energy sources. Why nowadays we are having more importance for the renewable energy sources. As you know, we are mainly nowadays we are all are using different type of energy sources, right? Petroleum products are there, otherwise wood we are using, or another type of biomass. So many things we are using, but what is the main difference of these energy resources and what is the importance for the renewable energy sources? Let me tell something briefly about that, then I will indirect into my topics. Okay, so first, renewable energy source means I will tell you one example. Today or every day, you can see our petroleum value or the rate of the petroleum is increasing day by day. What is the reason for that? Because every day we are consuming petrol, right? All the vehicle and everything is now running with the help of petrol. Why the rate is increasing? Then the usage, one of the reason is usage is increasing. Another one, how we can generate this petroleum product, that we all know the petroleum product is generating from the fossil fuels. How these fossils are generating, that will take long time, right? So due to this long time duration, the petroleum product is developing. So what is happening here? If you are consuming more amount of petroleum product, the amount of petroleum product is decreasing, but generation is not at all increasing as well, right? Because the generation, we can't make generation for the or generating this petroleum product within 1 or 2 days. So that is the main reason. So this type of energy resources we are mainly calling as a non-renewable energy resources. The meaning is, if you can't generate instantly, or if you can't use every day, if I am using today some percentage, tomorrow also I can use that much percentage, means already the availability should be same, right? That is not there. So that type of energy resources we are telling or calling as a non-renewable energy resources. So as you all are familiarized with the petroleum product, that's what I take that example only. So as we know, nowadays we are consuming very huge amount. So in future or after some 10 year, what will happen for that type of energy resources? That amount will be decreased like anything, so we can't able to get it, or normal average person can't able to buy that type of energy resources. So what is the main thing we should check? Other than this type of energy resources, what is the another source that we are able to get it? So how it should be? It should be cheap, and it should not do any pollution, right? That type of energy resources we need. So we are mainly focusing, or we are concentrating on that type of energy resources that is known as renewable energy resources. I can tell you example for renewable energy resources such as solar, wind, biomass, etc. But I will tell you with the solar energy, because you all know nowadays in nearby you can see so many houses we are mainly using solar panel. Why we are using solar panel? We are able to get uh, our required amount of energy from the solar. So with the help of this type of renewable energy source, we can go, or we can run our smart grid, microgrid, as well as electrical vehicle. So what are the application is there, that only we are going to see here. So hope you understood what is the importance of renewable energy source. So nowadays so many researches are going on. So we will see a small introduction only today. I'm going to talk about this topic. So these are my outline of the presentation: integration with smart grid, then distributed energy resources, energy storage, application of renewable energy to smart grid, integration of renewable energy with microgrid, and integration of renewable energy with electric vehicle. So first my topic is integration with smart grid. Before going to integration, I want to discuss with you what is smart grid. Okay, so the name, or it is announced by US by President Barack Obama on 8 January 2009. You already know the term meaning smart. What is the meaning of smart? In a classroom also you may heard, we will tell one guy he is very smart, right? When we will tell when that person is smart, he will be more active, he will respond quickly, he will do all the work in perfect time, or with he will do all the thing in on time, right? Like that one person, you may think that we will tell by seeing that type of one person, we will tell, yeah, he is smart or she is smart, right? Same way here, smarter means in the grid or in the power system, the generation, transmission, distribution, and customer participation, operation, market, several service provider, everything should be smarter. Then only overall I can tell my grid also is a smarter. Okay, so overall objective I can mention that smart or best or optimal utilization of all available resources. That means if I will give any work for any person, I'm giving some input also. By using that input, how he can manage that problem, then I can tell he is smart, right? So that is the meaning of smart. So I can tell you in a very animated version what we mean by smart. Okay, as you know, this picture is familiar, is for all of you. So what I want to tell you here means, what you mean by smart, that is my main thing. Smart means the thing which is smart and robust, then only I will overall I can tell that will be smart. So let me explain first. This figure, this is indicating his arteries, everything hurt, everything you can see here. The meaning is the blood or blood circulation is very good in his body. So what he mean by mean, the energy, the person will be having much energy, right? So this person with a 100% energy person only, so this person is strong, or he is not weak at all, because he is having much amount of energy. Another this figure you can see here, this brain, and brain through spinal cord, you can see in all over the body part we have connected from the brain, right? So what can I tell? He is very quickly responding person. That means he will take every action instantly, because he, you can see that biological part I am not going, but you know what is the brain function, right? If we are doing any work or anything, so immediately we will get in. Okay, so what will be happen?
Abhilash, please mute your audio.
Okay. sorry for the interruption. Let me continue. So here, brain from the brain, he will get all the signal fastly, right? So he will be spontaneous action. He will, and you can see all the part of his body also. He is able to get the response. So what can I tell? The person who is very energetic and very spontaneous action, his brain also very active. That type of person you have seen, right? Our Superman, the Superman means the person, he is very intelligent and very energetic person. Same way I can tell you our grid also, the grid which is having very much energy and as well as very spontaneous active, then the grid also we are calling as a smart grid. Okay, so this figure, hope you all get an understand about the what you mean by smart grid. Okay, so as per definition I can tell you, as per definition by National Institute of Standard and Technology USA, they have given the definition for smart grid such a way that a modernized grid that enable bidirectional flow. So this bidirectional flow, the term is very important. Let me explain later. uh, Energy and uses two-way communication and control capabilities that will lead to an array of new functionality and application. So this is the definition for a smart grid. Okay, so as per IEEE also another definition is that that means it is a smart grid is a large system of system where each functional domain consists of three layers will be there. First one is power and energy layer, another is communication layer, and third one is IT and computer layer. So you can see a normal grid is there, whatever not our means conventional grid, that is not smart grid. So what will be the difference I am going to show you guys, but prior that I can tell you the main important point is this communication layer. So as we know, if we want to do our work very clearly and very spontaneously, we need first communication, right? First the person or wherever in our grid also, we should know where the fault is occurring, or where is the problem occurred, or where the load is needed, where is energy needed. That everything how I will come to know through the communication. So communication layer is first important point. Another is IT or computer layer, that in that only controller action is happening. So by seeing these two layers, that means power and energy layer will be there all the type of grid, but this communication layer and the IT or computer layer will give you my system becomes smart. So as I mentioned, I can tell you, or we can do one discussion about what is the difference between the conventional grid and smart grid. Okay, so let me show this one in the no, sorry, in the tabular wise. So here different characteristics are there. We'll see each characteristics how it is different for conventional and smart grid. Okay, so first one, it is architecture. So as I can tell you, architecture for conventional grid is vertical. Let me explain what you mean by vertical. So you hope you all know, as you are electrical based student, we know the basic power system. What do you mean by power system? In the power system we are having a generation, then transmission, at last load or distribution. Correct. So this how the power flow is happening. First generation side the power is generating, then that will be transmitting, that should transmitted to the load or distribution through the transmission line. Correct. So this flow is happening in one way, that means from the generation to the through transmission to the distribution. So this one line power flow is happening, that is known as vertical structure. That is for conventional power grid. But smart grid mean it is not like that. There will be having distributed structure I will show you in the figure, then I will explain that. Okay, that is not in one way. In between we will have different pathway for the power flow, that is known as distributed structure. Okay, so next is consumer participation. That you can see, as you may see some home, or in your home only you are nowadays we are installing the solar panel, right? So how it is consumer participation is coming means, in the conventional power grid we don't have any participation. We are getting just as my home, if I am taking example, in my home I am getting just a supply from the grid that I am utilizing. So how much supply I am taking, as per that we will pay the bill, right? That is for the conventional power grid. But now smart grid, you know, if I am having some solar panel, or I have installed or mounted solar panel in my home, I am generating my own supply, right? How much power supply required for me, that I can generate. And if there is anything is left over, what I can do, that extra power I can give back to my grid as well. So what is happening there, I am also a producer, right? I can consume also from grid as well. When it will happen, is there any problem happen in my solar panel? That means sometime due to raining time, we know, during rainy season we won't get much solar radiation. So what should I do? I won't get much energy from the solar panel. So that time how I will get the power supply? I have to contact my grid only. I have to get the power supply from the grid. So in that way, consumer, I am a consumer, right? Obviously I am in smart grid also I am a consumer. I can get the supply from the grid, as well as if I am having extra supply through my solar panel, I can give it to back to the grid. That is about consumer participation. Next is generation and storage option, that is not needed, not or necessity things in the case of conventional thing, but in the case of smart grid we need it. The storage is important, because as I mentioned, if we are using wind or solar panel, we know that won't give you every time supply, right? For in the case of solar, what will happen during night and during rainy season or less solar radiation available, that time we are not able to get much power, right? So what we will use, we will use storage. That some battery we will use, I will show that later. So that is about the storage option. Then power quality. Power quality means in our previously, when we are using the conventional power grid, you may see we won't get a much good power, right? uh, that means I can tell my power quality is very less. How can I tell you? That means you may see we used to tell today, voltage is very less. Sometime when we are trying in the night and all, if you are trying to iron your dress, that iron box won't give you much heat. What is the reason for that? That time the voltage is not there, right, much. So we used to tell, oh, it is low voltage. Or sometime our normal lamp, not CFL lamp, I am talking about. mm Previously we used to one lamp, no, incandescent lamp we will call. That lamp light won't give much illumination, then we will tell, oh, voltage is not there. The meaning is the quality is very less. Only they, that time that grid will try to give you all the time supply. That means they will focus on the outage. Outage means there is no interruption in the supply, only is telling outage. So they will focus without a outage, they used to give the supply, but supply is having very less quality. But smart grid is not like that. They will ensure that we should get a supply such a way that both, which one, both the quality and the without outage. That is the main thing. Next, new product and service, that and all very limited in the conventional grid. But here smart grid, they are every time they used to check new product and services and all. Same way optimization also, it is very poor for conventional, but it is a good way. We are getting different type of management in the case of smart grid. Next, self healing. Self healing, it is like what is the word meaning? Same way, healing means if you are having any diseases or any problem, that we will try to solve it, right? That is healing. So same way here, smart grid can able to do, or so self healing, that property is not available in the conventional power grid. But you can see smart grid, they will try to do the self healing as well. Next, same way, cyber attack. Cyber attack will be vulnerable to cyber attack only normal conventional power grid. But cyber attack means they will try to, somebody will try to means theft the voltage, that and all, and they will try to attack our communication. That and all will try to do. That is cyber attack. That will be, we are resilient to avoid that. Who? Smart grid. Okay. Next is disaster manage. As we know in Kerala nowadays, we are having so many problem, flood and all, right? So due to that time, first, what is the main issue we are facing? There won't be any supply, right? So that and all will be affecting very fastly for our conventional grid. But smart grid, it is very less effective for the smart grid will be very less due to disaster. Okay. Next, event analysis, that also will be slow and tedious event analysis, but smart grid it will be smart analytic. Okay. And forecasting also will be there. Same way, communication as I mentioned, how the power flow, same way only communication, only one directional. That way in the conventional grid I'm having only one way communication, but in the smart grid two way, you know, right? If I am talking, you are only listening, but that is actually not proper. If you are telling something to me, the meaning is you understood something, right? So you are replying to me. So that communication, two-way communication will be always effective. That is for smart grid. Next, predictive. We can't predict. Non-predictive only conventional power grid, but it will be predictive for smart grid. And intelligent, limited intelligent, as the name we know, but smart is more intelligent. And efficiency, as I mentioned, they are not at all bothering. Conventional grid are not at all bothering the power quality. So poor efficiency, but smart grid is mainly focusing on the efficiency. Okay. So that and all are about the difference or comparison between the conventional grid and smart grid. So what is smart grid enabler? Actually, there are different types of enablers are there. Like we will get clean and flexible generation, right? So renewable energy means like solar, wind, that and all. Obviously or always it will be clean energy resources only, and it will be flexible transmission only, because nowadays we are using fact and HVDC devices. Then energy storage system is the system wide secure communication network. Automation is there. Active distribution network is the sensors means because as I mentioned, smart grid, how it becomes smart, it should act immediately, right? So it should know where the fault is occurring. How we will understand the fault? With the help of smart meter and phasor measurement unit. Next, smart analytic is happening, and market and regulatory framework. Next, some word term you may see related with the smart grid, that let me explain. One is prosumer. Prosumer means the meaning is the person who is a producer as well as who is a consumer, right? That is the prosumer. Like as I mentioned, in your home, if you are keeping a solar panel, what will be happening? That with the help of solar panel, you can get the supply, right? So that supply you can utilize, and extra is there means you can give it to back to the grid. But sometime you can take supply from the grid as well. When you are taking supply from the grid, you are a consumer, but when you are giving back to the grid, you are a producer. So who you are a combination of producer and consumer, so I can call you prosumer. Next, virtual synchronous generator. That means in the normal case, there is less of inertia. So extra inertia we are adding with the help of virtual synchronous generator. Another is advanced distribution management system. This is actually, as I mentioned, they are having communication and they will understand all the problem. After understanding problem, they should take some remedial action about that, right? To do that, they need some management, that is advanced distribution management system. Next, as I mentioned in the previous slide, distributed energy resources. The meaning is in the normal or conventional grid, you know who will be our generation. Most probably our generation we are getting from the power plant. That means different power plant, you know, right? Hydro power plant, thermal power plant, nuclear power plant. These are the main power plant available in India. But distributed energy resources means instead of power plant, that also you can utilize. Along with that, we are using some other type of renewable technologies, such as photovoltaic. Photovoltaic only India now aims at 100 gigawatt by 2022. Then solar thermal. Photovoltaic and solar thermal is belongs to solar panel or sun solar energy only. From solar energy, if you are converting solar energy to electrical energy, we are calling it as a photovoltaic. Next, solar energy to temperature, that means thermal energy means that we will call it as solar thermal. You may heard, right? Solar cooker, then solar space heating, everything that and all with the help of solar thermal. Next, small wind system is the large wind system is the biomass. Okay, so what are the storage? As I mentioned, these all the renewable source have some problem. That means you won't get every time sun radiation, you won't get every time wind, right? Biomass also most time whenever you are getting that time you will get more, right? So what we need actually, we need some storage technology. That means when you are getting more energy from the resources, what you should do, you have to store it. So for that, what are the different method? One is mechanical, electrical, chemical, and electrochemical. So these are the different energy storage I mentioned here. Means mechanical, you may heard flywheels, CAES, or pumped storage system. This and all mechanical storage. Electrical storage means supercapacitor is there, and SMES. These both are electrical storage. Chemical storage is fuel cells, and electrochemical means different type of battery, lithium ion, zinc based, lead acid. This type of battery will come under electrochemical storage. Next is smart grid network. As I mentioned, here I can show you what is the difference between vertical structure and distributed structure. You can see here, normally this light blue is indicating our conventional power system. Okay, as I mentioned, power system means you will be having one generation, then transmission, then the distribution. Correct. Distribution connected to different load. Load may be residential, commercial, or industry. So here you can see what is happening here. So here we are having generation is connected to transmission, then transmission to distribution, then distribution to, that is our normal conventional system, that is in light blue. But this is all arrow, you can see it is a unidirectional arrow. But when it will come in smart grid, you can see here almost all the arrows are energy storage extra came into the picture. Then all the sources from the supply to the load is in bidirectional. The meaning is we can give it, if they don't want or they are giving extra, they can give it to back. And all the communication also is happening along with the smart grid. So this is the picture will make you understand what is the main difference between the smart grid and the conventional grid. Next, in the renewable generation also we are having some few technical challenges. Main thing already I mentioned, intermittent generation. The meaning of intermittent generation means we are not able to get continuously supply or source from the renewable energy sources. I can tell you example, sun. When you are able to get the sun solar energy only maximum or mainly you will get from 10 a.m. to some 3 p.m., right? After that you won't get much energy, or in the night you won't get at all, and in the rainy season also you won't get, right? So this and all is known as, that nature is known as intermittent generation. Another is voltage and frequency control also required, because the source is not in under our control, right? So sometime it will produce very high, sometime it is very less, so the control action will be very difficult. Another due to that only, system instability, stability, that term also, right? The simply I can tell you, always we need our voltage should be in a rated value. Single phase means 230, sorry, 250, and 230, then three phase means 415, right? The rated voltage should be there. If there is any change in voltage, we can tell voltage instability. Same way, frequency, standard frequency of our India is 50 hertz. There is no change, there should not be any change in frequency. So these both will affect the system instability. Another is power quality issue. Power quality issue is another problem. Last problem is power management and maximum power tracking. So these are the main challenges. Same way, transmission wherever, that's what the renewable energy source I was talking the challenges. Same way, transmission also some challenges may happen, that is due to right of way. That means the way wherever the transmission line is going, that under that path is they should get some right of way for that, right? So that is the another land acquisition and renewable integration and grid management. So some measures also I have mentioned here, that all will help us to solve these challenges. So I can tell what is the major challenges in the all together. We see separately what is the challenges in the renewable energy sources. and in the transmission. And but together I can tell you the major challenge is the first one is reliable and fast communication should be there. WAMS means wide area management system, that will be integrated with the SCADA, DMS, CMS, everything. Then suitable converter, because converter is a main part of this type of grid, so that is very difficult to find out. And optimal sizing is another issue. Dealing with the intermittent generation, that term already we have discussed. Then adaptive protection and distribution network microgrid protection. Then regulatory changes, everything will come under major challenges. So we can tell you what are the application of renewable energy to smart grid. So as I mentioned, the energy, how it should be environment and sustainable development. And it is why we are not using fossil fuel, the main reason is limited period usage only available. Then reduce greenhouse gas emission. If you are using a renewable energy source, that means carbon emission due to due to petroleum product are very very high, so it making very a big amount of pollution, right? But this green gases will not make any pollutions. And distribution generation system connected to LT distribution system. And so we are mainly focusing on the, or we can do renewable energy sources such as wind, solar in rooftop photovoltaic, or other distribution generation such as hydro or biomass, you can use it. Next topic, that is integration with the microgrid. So as I mentioned, why we mainly want to go for going green, that you have seen nowadays, we all will tell we have to going to green, right? The main reason is the pollution only, right? So other type of source energy resources what we are using nowadays, that petroleum product will make the huge amount of pollution, so we have to avoid that. So we need a sustainable renewable energy has been found, future green energy solution. Sustainable renewable energy means what is that? That only we are discussing, right? Our solar, wind, biomass, everything. That will be good option for our future. And so in that, another important point is microgrid. So what is the main difference between grid and microgrid? Means microgrid can either we can use this microgrid, means mainly microgrid have one generation, transmission and load, but it no need to connect it with the main grid. That means I can tell you example. You have seen ship, right? Our ship is not in where it will be there. It is not always in the seashore, right? It will be in the sea. So how we will give the supply to the inside sea? That will be difficult, right? So in the ship only, what we will do, we can connect some wind turbine, because whenever the wind will be there, or most probably solar panel we can connect, right? So inside the ship only we will make a setup for power generation. Then that actually transmission won't be there, no need of transmission for that. And there only we will consume load also inside that. So that is an example for microgrid. Same way I can tell you one more example, satellite. Correct. Satellite, how we are getting supply the satellite? Can we supply from India to satellite or world from satellite? That is not possible, right? So there only we will try to develop some supply, and that will be utilizing that type of that is also another type of grid that we are calling microgrid. So microgrid are, how I can tell, multiple distribution resources. That means different type of distributed resources will be there. That means solar you can use, or biomass you can use, or wind you can use, like that. But it is controlled as a single entity with respect to grid. But they can be more than that also. A fundamental shift in the way of electrical grid is built, operated, and financed. So this is the about the microgrid. So in this figure, I will help me to explain you more about the grid. So first I will talk you about two types of microgrids are there, AC microgrid and DC microgrid. What is mean by AC microgrid? Mainly I can show you first this line. This black line is indicating our bus. The bus means, where my generation is connected, from where load is getting supply. So generation is, you can see there are different type of generation. AC generation will be there, DC generation will be there. But my, as it is a AC microgrid, my this bus will be in AC supply. Okay, this is AC microgrid, right? So this bus will be AC supply. So what type of supply I should give here? AC generator, obviously it will produce AC supply, that will connected directly here. DC, what supply it will produce? DC, right? Solar panel, you know which supply it will produce, that is DC. So DC, how can I give to AC bus? I should convert. So what should I use here? One inverter. Inverter will convert the DC to AC and given to here. Same way, energy storage system, obviously battery. You are using normal battery, right? What is the battery supply? That is DC. So battery also, if you want to give supply or getting supply from battery, I need DC. So what I should do? I need a converter. So here all the supply I'm making into AC and given to the bus. Same way here, load also same thing happening. AC load means directly given supply to the AC load, but if you're having DC load, you need a rectifier. Rectifier will convert AC to DC, then given to the load. So same way DC microgrid also we are having. DC microgrid, this bus will be DC bus. That is the difference. So whatever you are generating, it should be in DC. If it is AC, I need a converter. Otherwise, you can connect directly to the DC bus. Same way load also. So that is the two different types of. So you have to understand this much. There are two different types of microgrid. One is AC. AC means main bus will be AC in nature. Another DC, DC in nature. Okay. So microgrid also have few challenges. What are the challenges? Mainly voltage stabilization will be the power management, PQ management, uh, protection, grid integration, stability issues, and island operation. But some research and development also needed in design of microgrid architecture, AC and DC microgrid, converter topology, because you have seen in the microgrid we are using lot of converter. So MPPT sim, these all are nowadays undergoing through different researches. So if you are anybody is interested to do the higher studies also, you can go through any of these areas, right? This and all are nowadays very important in the research areas. So this grid, I was talking about the classification. One of thing we have seen, that is microgrid. Same way, macro grid also there. This is little more big type of grid. As I mentioned, ship is NDR one microgrid, or satellite, it is another NDR microgrid, right? So, and other than that, small type of grid also the means microgrid I can connect with the grid as well. That is microgrid, but there is no connection with the grid at all. That is macro grid. That will be very small, as name is indicating, macro. That we can use either fossil or renewable. Renewable also two types are there, strong and wind. Microgrid, as I mentioned, isolated and interconnected. The meaning is, if you are connecting with the main grid, that we will call interconnected or grid connected. If it is not connected with the grid, we will call isolated. Then energy consumption, just I am showing it graphically how much it in India and world, and per capita electricity consumption how much in India and world. But you can see energy demand are more than generation. Correct. You can see 530 only. We are here, and one more thing you can see here. Every year in 2003 and 4 we need energy demand up to, 572 only. But you can see it was increasing very exponentially. That means increasing very much high, right? So that is showing here. Then this is another utility challenge also, same thing, different type of consumer we are having, right? That also another important challenge, because we have to satisfy the all the type of consumer. Industry is there, residential area is there, other commercial area is there, everything is there. There everywhere we have to means we have to connect everything together. Then how this renewable energy integration is happening? As I mentioned, so many types of energy sources are available that we can do connection together. Then the main goal of this renewable energy integration is mainly we have to do design, planning, then operation of electrical grid. Why we are doing this means mainly one point is carbon emission. As I mentioned, nowadays what we are mainly using, we are using a fossil or petroleum product, so that will be producing very much of pollution, right? So that we can reduce, then lower the cost of electricity because power plants and all, that is very far from our place, and for transmission only it will take much distance, and so losses are more, so the cost also will be very high. So if you are using renewable energy source, that means in your home only roof, if you are keeping solar panel and you are able to get the electricity or supply from that, the cost will be very less. Then enhance reliability and security and resiliency. Then we can use enabling plug-in electrical vehicle. Plug-in electrical vehicle means you can connect with electrical vehicle. That means electrical vehicle we need supply, right? That also we can give it. So that is about the microgrid elements to consider. So all over idea, whatever I have mentioned only, I have mentioned here. So the same thing, whatever we discussed only mentioned here. Okay. So next, as we know, the different type of power generations are there in India. So in overall world, so that is you can see hydro, coal, and gas we are using, and small percentage of renewable only we are using. In that also, in a world we are mainly focusing wind. Correct. Then small hydro biomass. Then in others only is solar is coming. But by seeing in India, you can see we are first chance for means first position for wind only, next solar, small hydro, biopower. These are the main thing we are using. Okay. So next issues in renewable energy integration. Already I told we can't predict, right, whether tomorrow I will get sunlight nicely or not, whether tomorrow rain will come. That much prediction is not possible. That is the one issue. Then scheduling and flexibility and incentives, day ahead market participation and reliability commitment, balancing the authority coordination, reserve capacity, everything's are problem. Then another challenges with integrating renewable energy source to electrical power system means the main problem, whatever I discussed, that only the intermittency in the nature. That means we can't predict how or how much energy you will be able to get in each day. Another the problem is depending on local system penetration. That means any fault can trigger. That means any fault is occurring, so suddenly, if suppose in your home you are concentrating only solar panel, means if any problem is happening, that will affect entire your home, right? So we won't have any other means solution to do that immediately. So that is another issue. So these are the mitigating measure in renewable energy integration, like flexible generation, demand side management, everything. To get a good result, we are having some standard, IEEE standard. That is actually for doing this grid integration. What is which IEEE standard we are focusing means IEEE 1547. Okay, so there under that so many standards are shown here. These are the main standard. As per that, we are making grid integration. So even though during that time also some opportunities are there as well as risk also there. Opportunity like always I told, low cost, avoided cost benefit, and demand response, everything are the value opportunity. But risk means negative power impact will come, utility customer de-intermination, everything will come under the risk. So main goal of the distributor resources business model means mainly we have to some objectives are there, right? Like means ensure design and operations are grid friendly. All should be it should be eco friendly or like friendly type we should do. How much, what is your requirement, as per that it should work, right? So that means there is no harm will be there. And it provide incentive to cooperative. You should get some incentive, right? That means both party, customer and the every producer and customer both should get some benefit. New value added growth opportunity, that means we are getting so many new services as well. So that same way, if you are doing microgrid field test, that means how can microgrid benefit an individual customer and grid. So individual customer and grid also both we are getting some benefit, right? What are the benefit mean? One is providing resiliency to critical facility. That means whenever any urgency is needed, also we are getting some supply. Then utilize utility on the utility sited asset as well. And last one, demonstrate ancillary and grid stability service. So what I can tell you, after some year we can see in our case only we are having so many options are available, right? We can buy electrical vehicle in our home roof only. We can keep all the different type of energy sources, and our all the devices will be utilizing this type of energy resources. Then to do this and all things, already as I mentioned, IEEE standard, some policies also there. Then with the help of these policies and all we are doing means, I can tell whatever we are doing that will achieve in the long term. Okay, we will think what we are making changes, whether it will be long term. Yes, surely if you are doing with this policy and all, it will be long term. Same way, some options for utility and grids are there, that is mentioned here. That means, as I mentioned, distributed generations means different type of resources you can use. Energy storages are there, and microgrid solution, everything is available. Same way, opportunity for a utility also. I know almost time is up, so I'm going little fast. So different types of utility opportunity also we are having. Okay, so same thing only I have explained here. The what is the utility of the future mean, we know what is the iPhone, how iPhone is working, right? iPhone create a platform for customization. Customization means as per your convenient you can utilize your iPhone. That's why nowadays everyone is liking iPhone, right? Same way, I can tell you the utility grid will do same thing. As per your requirement, you can change it. If you want to use EV, you can use EV. How can you want, whether you want to act as a consumer or producer, you can act as consumer as well as producer. That all the facilities available. So that only, so we will see, we can understand so many questions will arise us in that business term as well as technical term, that and all I mentioned here. But we are having solution for all these questions. Same way, I'll ask my topic, that is integration of renewable energy with electric vehicle. As you know, we are going in the era of usage of electrical vehicle. So how we are utilizing as from the renewable energy sources, we can able to charge the electrical vehicle. So here the term you may see vehicle to grid. The meaning is vehicle to grid, V2G is there and G2V is there. G2V means grid to vehicle. The meaning is from vehicle you are able to give supply. That means vehicle, inside the vehicle obviously what is there, battery is there. So if in my home I am lack of supply, or then I can get supply from vehicle. That is known as vehicle to grid. If in your home you are having supply, I can give to vehicle as well, right? That is known as G2V, that is grid to vehicle. So there are so many future direction also there in the renewable energy integration research, that is stability and integrity, protection, strongly interconnected energy management, intelligent and robust energy. These and all are main topic for the research. And I would like to conclude about my topic here. That is, as we know, our electric sector in India is installed capacity is almost 254 gigawatts. But at the end of September 2004, okay, in that means India is the third largest producer for the electricity in the year of 2030. That means first position for Japan, then Russia, after that India. Okay, even though we are facing 90 percentage of global renewable share to meet our daily need, because every day, we need some amount of energy, that in that 90 percentage we are lacking now as well. So how we will achieve this? So we want to focus renewable energy sources. So we are focusing renewable energy sources to achieve this energy also. Okay, so this is my references, and what I want to tell means together shaping the future of electricity. Thank you. Now, anybody is having any doubt, you can ask me. I will help you out.
Okay. Thank you, ma'am, for your wonderful presentation. Hope that it will be more effective and informative for our students. Thank you. Thank you so much.
Thank you, ma'am. And I would like to thank you, all of you who are under this webinar. And I would like to thank HOD of Triple Department as well to give me opportunity to get small webinar. Thank you all.
Thank you.